الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. My name is Ahmad السديري. I finished the Masters in Aerospace Vehicle Design from Cranfield University last September. And my topic today is Conceptual Design of Desert Search and Rescue Aircraft. The potential of making this research is the self-experience and the social experience in lost people in desert in Saudi Arabia. When I was 10 years old, we ran out of fuel in the middle of unfood desert, and I walked with my father for around 5 kilometers until we found one Bedouin who helped us and support us with fuel. And my father's job as a civil engineer in the Ministry of Education make him go a lot of times inside the desert, and a lot of times he stuck for 10 hours, and last November he stuck for about 20 hours. So this was the main potential of making this research. If we want to talk about the aircraft design is divided to 3 main sections. First is the conceptual design, second is the preliminary design, the third is detailed design. After detailed design made, manufacture could be done. Explaining that from my own experience, if we talk about this project, it's a conceptual design. It's give the basic aerodynamics and configuration and geometrical data for the aircraft. After that, the preliminary and detailed design go more detailed in the aircraft design. In the pre-master, in my pre-master, I did some preliminary and detailed design of the wing front spar to fuselage frame joint of PC-12 aircraft. So you can see the level of details which reached in this project. One other experience in preliminary and detailed design is the group design project in Cranfield University. We were given a conceptual design designed by Professor Howard Smith, and inside this, the design was a space shuttle, SL-12 space shuttle, and it was divided between 77 students from 21 countries. Each student go to a high level of detailed design inside the aircraft. As we can see, this is the space shuttle, and my own part of the detailed design was the support structure for the expendable external tanks. After that, talking about the manufacturing, this could be one level of manufacturing, which is manufacturing of Saqr al-Jazeera 5 aircraft in King Fahd University of Petroleum and Minerals. I did experience the riveting and bending of sheet metals for this 2 passengers small aircraft. Talking about my project, the aim is to make conceptual design of desert search and rescue fixed wing aircraft by using variable optimization. The project starts with missions and requirement. I put my own mission and requirement. Then competitors' literature review was carried out. After that, the design synthesis was carried out. Then multivariable optimization was done to change some parameters in mission and requirements, and to change other parameters in the design itself. Finally, when the design was fixed, a small CAD model was made to represent the aircraft, and the final aircraft was represented. The mission and requirement in all commercial or fighter aircraft, regularly the mission come from the customer, and the customer could be an aircraft company, could be passengers, could be, and inside this project, I was the customer because I was lost in the desert and I need this aircraft to search and rescue me. So, taking the design from this point of view, this is, I collect some data from social networks, from newspapers, for people lost in the desert, and there was search and rescue for them. If you can see, the blue signal is for the people who was found by ground patrol, and the air patrol searched for them, but they didn't find them. And in this case, the person who was found, it's last September, maybe 2 times the helicopter go above him, but they didn't recognize him. The green is they found them by ground patrol, and the yellow is they found them by air search and rescue, and the ground they didn't find them. The red one is which it was very sad moment. In 2006, it's Al-Atiq family, God bless them, and they, by air battle and by ground battle, they searched for them for 2 months. They didn't find them. They found them only by instance. So, observing these locations and observing the airports, which my aircraft could take off and land in this airport, I could make a mission for my aircraft. So this is the mission for my aircraft. I wanted to take off and take off from less than 500 meters to achieve short takeoff and landing capabilities. I wanted to cruise to 350 kilometers to reach the areas of people lost, and with a height of 2.5 kilometers to design the aircraft to be unpressurized and avoid the complexity of pressurizing the cabin. And the search was I made it to be 8 hours to avoid the fatigue of the crew. And also I put the elevation to be 1 kilometers for visual and camera aid search and rescue. For example, if we see this photo was taken with an elevation of about 1 kilometer and 100 meters. If we recognize this person can be hardly seen in this photo because of the contrast of between him and the background. But the other person is easier to see him. Also, the second thing is the forward-looking infrared camera. If you can see, here is the detection and recognition and identification capabilities of that camera. I found one camera which could operate between 35 millimeters up to 135. So I found from this graph that the camera, if the aircraft fly in 1 kilometer's elevation and search, the person could be identified easily. Desert takeoff and landing, less than 500 meters. I did a fast investigation on Edinburgh desert. I found a lot of places which the aircraft can land in less than 500 meters. Now, if we talk about the competitors are not just the same kind of aircraft, fixed-wing manned aircraft. It could be satellite, it could be helicopters, it could be UAV, and the main competitor is the UAV, because it's very cheap, and or unmanned air vehicle, because it's very cheap and could fly to long endurance. But to make my aircraft more special, I added that the aircraft could land and take off from desert capabilities. So I collect about 34 aircraft data to start investigation and compare with my aircraft. This is DC-3 aircraft. It could land and take off from desert. This is Aramco, Saudi Aramco aircraft. This is Cessna Caravan. It's used in Namibian tourism companies. It's also can land with an unpaved airways. This is Twin Otter 400 aircraft. The special thing of this aircraft, it can land and take off less than 400 meters. This is a Firebird aircraft. It used push-up engine with this kind of configuration. And one special thing about it is it can fly for along Honduras for 30 hours. This is Optica aircraft. We can see that the environment of the crew is very comfortable for search and rescue. This is PC-12 aircraft. This PC-12 could be changed from business aircraft to a flying hospital in just 3 hours. So it has a lot of functions. So this is one of the success aircraft. So one thing which I want my aircraft to be multi-role aircraft. This is spacecraft one Virgin Atlantic Virgin aircraft. We can see that it has 4 landing gear. So I made my initial layout. I put the aircraft to be 4 landing gear aircraft, push-up engine, glass cockpit. I discussed that the aircraft can covered by solar cells because of the high solar energy in the desert regions in Saudi Arabia. I decided to put forward-looking infrared. I decided to put 6 passengers, 3 crew and 3 passengers. So the design science was carried out. The first thing is the weight estimation. The initial weight estimation is done by some equations relating to the previous aircraft. Second thing is the wing loading, W over S. The wing loading, S is the wing area. So the wing loading have some equations for stall case, takeoff case, landing case, cruise and range and endurance. After that, when S is fine, I multiply the wing loading by, I divide the wing loading by the weight estimation, so I find the wing area. After that, I can find the wing geometry, the wing area, the aspect ratio, the wing span. Then the physiological geometry is found. The external, the physiology is the body of the aircraft, the external layout and geometry, and the interior also. Then the tail geometry, the landing gear. After that, with knowing all of the geometry of the aircraft, the lift coefficients can be found, the drag coefficient, the parasite drag, and then lift-induced drag. Then the stability could be made, and the structure of the aircraft represented by natural force over and the velocity diagram. The final thing is the power loading, which is the horsepower, because the drag is pulling the aircraft back, and the thrust is reflecting that force. So the power loading is divided by the weight. And after knowing all of this, I did the multivariable optimization, which is iterating the weight again to the initial weight estimation. Yeah. So this is some equations which I used to represent. This is, for example, the component weight. Each aircraft component have its weight and location. This is the wing loading. This is the parametric analysis between. The objective is to make the power loading as up as possible, to decrease the power of the aircraft, and to make the wing loading as right as possible to decrease the wing area of the aircraft. So after that, I used Excel solver to put some constraints depending on my mission and to search for the minimum weight of the aircraft. So inside the Excel solver, at each time I change the wing loading and power loading point and generate a point of the design. Then I found this parametric plot. As you can see, if the lift axis is the aircraft weight, if I want the aircraft to be very low weight, for example, the takeoff distance will be 3,000 feet, which will be a lot. The power will be low, but the stall velocity, for example, it's very high stall velocity, which is not needed. On the other hand, if I go up, if I increase the weight, the takeoff distance will be just 30 feet, but the power will be very high. So I searched for an optimum point, which was nearing that point of the design. So I decided to take that point for my design, and this is the final aircraft data. The weight is about 700 to 250 pounds, and the power is 366. So I fixed that design with that point. This is the weight components of the aircraft, the performance of that aircraft, the stability. Finally, the CAD model was made. Very fast CAD model, because the configuration was changing at each point of my design. Further work which I might carry out on this paper is to discuss the cost of that aircraft. I didn't discuss the cost. And cost could be itself a parameter in multivariable optimization. And also I'm thinking of making a small interface of the Excel sheet, of my Excel sheet, to make it like a good interface for aircraft design program. This was my presentation, and sorry for being long.
Thank you, Ahmad.
Thank you.
It was very nice and a good presentation. I guess you might have some questions from the floor, because if you've got any chance of being lost, like Ahmad. Any question from